So we're going to go through exactly the same steps for lesson 10.2 as we did on Friday. Let me refresh your memories. The first step is to find the axis of symmetry. Okay, axis of symmetry is what we need to find first. And to do that, the equation of an axis of symmetry, if you remember, an axis of symmetry is an equation of a line. It's actually a line that we draw in. To find the equation of that line, we use the formula x equals negative b over 2a. We have to select an a and a b out of our problem. The a is always the coefficient before the x squared term. The b is always the coefficient before the x term. We plug those into our formula, and we will get the equation. First, we need to find a and b. What is a? Where do we get a?
X. Y.
There's a 1 in front of that x squared that you don't see, so that's what a is. A is 1, b is the one before the x, so that's negative 4. So there's our a and our b. So we plug it into our formula. We have negative times negative 4. So there's a negative in the formula, and b that you're plugging in is also negative. We put that over 2 times our a, which is 1. And then we simplify this. On top we have negative times negative 4, that's a positive 4, over 2, which gives us 2. So our axis of symmetry is x equals 2. That is our axis of symmetry. So that means that's a vertical line at 2 on the x-axis. So we come over here to 2 and we draw a vertical line through 2. And that is our axis of symmetry. That'll be the center of where our parabola goes through. And then next, we have to find the vertex. To find the vertex, we plug our axis of symmetry 2 into our equation, which is, our equation is x squared minus 4x plus 4. I'm going back up to the top to write down what my equation is. And I only want the stuff that's on the right side. I'm not going to worry about the y is less than right now. For right now, we're going to deal with that later. Okay, so right now you just plug it into everything on the right side. So we're going to plug a 2 in. We're going to replace each x with 2. So we get 2 squared minus 4 times 2 plus 4. And again, you can put that right into your calculator. Put parentheses around your 2 when you're plugging it in. You will come out with a value. What do we get? 0. That is correct. So when you plug 2 in, you come out with a 0. That's how I get my coordinate point. That's how you get your vertex. The x is what you get from step 1. You put that right in there for the x coordinate of the vertex, and then when you plug it in, we come out with a 0. So our y coordinate of the vertex is 0. So now we go to 2, 0 on our graph and put a point. So 2, 0, and we put a point. That is the vertex of our parabola. It either opens up from there or down from there.
Going up.
Quincy, why is it going up? Why is it going to open up? No, because it's positive. Because if you look up here at the x squared term, if there's not a negative in front of your x squared term, it is going to actually open up and your vertex is going to be a minimum.
Oh,
if it was a negative x squared, then it would be going down, facing down.
We're talking about the x squared. Okay.
Yeah.
I was
So
talking
that's.
about the before the 4x.
Oh, okay. All right. Now, what's the next thing we do? Once we have our axis of symmetry and our vertex, do you guys remember what else we have to do?
You gotta put the next number in.
Yeah, we need 2 more numbers. 2 more numbers. And we're going to do that by using the x values that are either just 2 values that are just to the left of our axis of symmetry, or 2 x values that are just to the right of our axis of symmetry. So we could either do 0, 1, or 3, 4.
0, 1.
It doesn't really matter. We'll just do 0, 1. 0 squared minus 4 times 0 plus 4. And then we're also going to do 1. We're going to do 2 different ones here. So on the first one, on the top one, we know 0.
Students are to be excused at this time.
So we plug 0 in for x and 1 in for x. And then we come out with something. So that will tell us what our y coordinates are. What do we get when we plug 0 into that equation?
0.
4.
4. We plug 1 in, we get, should get 1, I think. Yeah.
Yeah, you did.
You get 1. So those are 2 more points on our parabola. So we're going to go ahead and put those 2 more points on our parabola. We have 0, 4, so we go 0 and then up to 4 and put a point. And then we have 1, 1 and put a point. All right, that's half our parabola. Now we do the other side. So we mirror it across the line of symmetry here. Now, before you go connecting the dots, some of you already have, I'm sure, but before you connect the dots, let's think about this for a second. This is where the problem becomes different from Friday's problem, because we have an inequality symbol up here to deal with. It's y is less than. Do you remember when we did linear inequalities where we had dotted lines and solid lines, and then we had to shade either left or right or whatever? That's exactly what we need to do here. So let me remind you of the dotted and solid thing. If it is greater than or equal to or less than or equal to, then it's a solid line. If it's greater than or less than without the or equal to, it's a dashed line. So if you look at our inequality symbol on this problem, it's y is less than. So it's just less than. It's not or equal to. So that means we're going to actually have a dashed line. Okay, and you're going to want to do the dashed line all the way up to the top. Like fill in the entire graph that we have, and it's going to look something like this. That'll be our parabola, and we've just dotted it in. And then comes time for the shading. If you look at it, it's y is less than. And be careful, this is getting people confused. So just listen carefully. It's either going to be above your line or your curve. It's either above the parabola or below the parabola. In this situation, since it's less than, it's going to be below the parabola. So that means we're going to shade everything below it. This stuff over here is still below the line. It's still below the parabola, even though it looks like it's to the left. It's still below it because if you think about it, this parabola goes on and on and on and on and on and on, right? So it's all the values below it. So we shade all of this except for the stuff in the parabola.
So how do we know that again?
Because it says less than. The symbol is less than. Less than typically means below, right? Less than is below.
So with greater than, we just color the parabola.
Yes. Now that's on an upright parabola. Let's think about this. If we had turned the parabola upside down and it was less than, what would we have done then?
Oh, the inside of the parabola.
Yeah, exactly. So it depends on which way your parabola is facing. If it's like an arch, if it's the arch, think about shading below the arch, right? We wouldn't shade everything above it. We'd shade everything in the arch, right?
That's the next one.
So, I don't know.
Probably.
Oh, the next one is an upside down one, yeah. So that's how you do those. We're going to go through these steps exactly again. And then by this time, we will have done this together like, this will be our 4th one to go through. So by now, these steps you should be getting it, okay?
Yeah.
All right, so let's move on to B. All right, letter B. We first need to find our axis of symmetry. So we're going to use the formula x equals negative b over 2a. We need to pick out what our a is and what our b is. What's a?
Negative 2.
A is negative 2 because that's what's in front of the x squared term. B is negative 4. So we're going to plug those two values in. We get negative, and then we're plugging in a negative 4, over 2 times negative 2. So on top we have a positive 4. On the bottom we have a negative 4. Positive 4 over negative 4 gives us, good, negative 1. So our our line of symmetry is x equals negative 1. So that means we're going to put a line of symmetry at negative 1. There's our line of symmetry. Now we take what we got from x and we plug it into our equation. I'm going to bring down the equation here. We have negative 2x squared minus 4x minus 3. We're going to put negative 1 in place of the x on every single x. So we have negative 2 times negative 1 squared minus 4 times negative 1 minus 3. With all these negatives and squareds and everything, just put it in your calculator. That way it keeps you from making silly mistakes, okay? So just put it right in your calculator. When we plug in -1, what do we get out?
-1.
We also get a -1. Yeah. So our vertex then is -1, -1. Okay? So -1, -1 is our vertex. And for this one, we happen to know that it opens down because it's negative. So we know that's a maximum. That's our maximum.
-2, -3. So we should do.
Oh, okay. Quincy says we should use -2, -3.
Yes.
Okay. We'll plug those in. So now we do our 2 points.
For -2, it's -3.
So we're going to plug in -2. We're also going to plug in -3. What do we get when we plug in -2 again, Bernice?
-3.
Yeah, -3. So we get -2, -3. There's 1 point. Here, what do we get?
-9.
-9. Okay. Sweet. I'll put it right into your calculator, exactly as you see it, with parentheses where it needs to be. Yeah, it is -9. I remember it from last hour. So now it's -3, -9. So we get -2, -3. -3, -9.
So then you
Hmm?
It'd be a bold line.
Yes, it is going to be a solid line this time. Okay, once you get those 2 points in, mirror the others. Okay, and it is a solid line because it's or equal to. So go ahead and connect the dots in a solid line. So then look back at our thing. It says y is greater than or equal to. So greater than or equal to means it's above that parabola's line, above the parabola's curve. So it's above. Had it been less than, we would have colored inside the parabola. And that is how you graph linear inequalities. I'm not linear, I'm sorry, quadratic inequalities.
You record.